Hey and welcome back to creating the procedural donut in GeoNodes. Last time we made the icing for the donut with the drips and everything. If you haven't seen that video, go ahead and check that out because today we're gonna start putting some sprinkles on top of the donut. So let's go into Blender and see how that's done. So this is where we left off last time. We've created the dough and then we created the icing. And now we want to put some sprinkles on top of this donut. This is one of the most common use cases of geometry nodes, which is scattering particles on surfaces. And you can do this in a million different ways and adjust it to every single little parameter you want. We're going to look at it in a very handy, simple use case, which you can implement in all of your geometry nodes scattering systems, taking just the icing mesh. And we are gonna put it straight into a distribute points on faces. This node you will be using a lot, so it's good to know exactly what it does. So we have two distribution methods. So it's random or this other thing that I'm not gonna butcher. So this option, we're gonna use that because it gives us more control and we're gonna need it. It will give us this distance minimum and the density maximum and then this density factor, which is going to be very handy. And then we have the random seed also here. So if we just look at what it outputs, you can see one big point, and I'm just going to do a set point radius. This is just a visual thing in this case right now, because we want to make kind of two different types of sprinkles. We want to make the normal like long cylinder sprinkles, and then we want to make some sort of like ball sprinkles on top of this. So we're gonna put the point radius now to small so we can just kind of see it in this scale right now. And you can see that there is one singular sprinkle on this donut right now, and that's because the density value is too low. Because the density value is actually relative to scale. So I can keep going and keep going, and now it's like more and more points are coming, and keep going and keep going. And this value is going to be so huge that it's going to be ridiculous to try to find a good value like this. So what we want to do instead is actually get a group input. That's perfect. So group input, and we're going to take this density. And we're gonna immediately get a new panel. I'll put it on the bottom, call it sprinkles, and then get this here. And this is sprinkle density, and we'll put the default value at 10. I'll show you why. Master density here, because now we can take this value and take a math node and just multiply it by 1,000, and now we have a lot of sprinkles, and that's too much actually. Let's put the default value to 1. So if I put that to 1, you will see like so. So let's put it to something like 5. Seems reasonable. And if I now were to join the icing with the sprinkles, you will see that some of them are up here and some of them are down here. And some of them are on the side, and that doesn't really make sense. Like no sprinkle is ever going to be here on this edge. You put sprinkles on top of the donut. So we will use this density factor value to say that we want sprinkles here and not in here. And easiest way to do this is to get the normal and separate XYZ And if we look at the Z value, you will see that that's already it. So if we put that into density factor and like so, it will take away all of the the sprinkles over there. And if we use a color ramp set to, I don't know, B-spline, and pull this kind of up so that there will be less sprinkles down here and sort of pulling more up top of here. And now we can actually up the value to 10, which is actually really good. So let's put the default again to 10. That's good. And then we will also take the seed and put it in there. And now it's again this, keeping it clean from the get-go. Like this. Okay. We don't want the sprinkles to be these points. We want them to actually be sprinkles. And if you've ever looked at sprinkles, you know that they're kind of this tiny cylinder that is a little bit bent. And so we're gonna actually procedurally model those sprinkles. And in the same way as we modeled the donut, the dough of the donut, we kind of want to do the same. We could use just the mesh primitive of a cylinder as our base. But I kind of want to have this organic random shape because the sprinkles aren't perfectly straight. They are bent slightly, or can be shorter or can be longer. So we want to kind of randomly create this, or procedurally create these different shapes. So we're going to again go for a curve, but this time a curved line. And then we get this. And what we want to do is get a value. So this is going to be the length of a sprinkle, and the longest sprinkle I've seen maybe a centimeter long. So let's do that. 1 centimeter, 0.01. And then if we use a math and divide it by 2, if we take this value, we want to put so that the center of the sprinkle is at 0, 0. So we want to put half of the length forward and half of the length backwards. So we can combine XYZ here and here. And we want to put 0.005 or minus 0.005 here and 0.005 here. So we get this. And to procedurally create this, we will take the divide and then math and multiply by -1. Like that. So now if I were to adjust this value, it will scale from the center of the origin from the sprinkle. We're gonna actually go up here into here. There we go. And then we want to displace this, like give it a little bit of random displacement, and we're going to do that again with some noise. And that noise will be, we'll get the noise texture and we'll get the set position. And again, we take this color value and put it in the offset and normalize it, and you will see that everything is gone because it is too big. Vector, or too strong. Vector math set to scale and do 0.001. Now you can already tell it's not anymore straight. If I mute this, it's moving, but it's moving, it's not bending, it's looking very straight because the curved line is actually just has 2 points, 1 point at the each end, and the set position node is just moving these 2 points, and everything else is just interpolated in between, so it will be just a straight line. So we need to add some more points to this curve to make it have more resolution. And with a resample curve node, we can do that. So we can give it a bunch of resolution. So let's keep it at 10 for now. And this noise needs to be a lot bigger, I think. First we put it to 4D because we want to have a seed, access to the seed. And we will put this noise to something very big, 150, like that. Let's make it weaker. Let's do 0.0, half of the size, half of the strength. And let's put this to 8. So then we have this kind of thing. Let's get an integer for the seed. So then we can change the seed of that and change the length of that. Perfect. And then the same as last time when you're using the curve to mesh, we're gonna take a curve circle, and you can see now it's a huge circle. Set the resolution to something really small. 6 seems fine, and the radius sprinkle is like 1 millimeter thick, so we're going to take 1 millimeter divided by 2, and that is looking like a sprinkle, but it's a tunnel, a tube, or a straw. So I'm gonna just fill caps so we get something like that. Then we will subdivision surface this like this to smooth out the entire thing. It's a really long sprinkle, I must say. Let's make it shorter, 0.007, 0.002, 0.005. Yeah, that looks better. And we can actually set shade smooth, just to kind of smooth out that pull on the sprinkle like that. Doesn't look amazing. Let's just look at the face orientation is 1. It's gonna be so small that that's gonna be fine. That's gonna be just fine for what we need. We could also have like before we do all of that, we can put in here a trim curve and then do a value and do 0.5 to 1, and then do a second one that's gonna be 0 to 0.4. And then we take the seed into here. So if I just change, we get a bunch of different variations, and then we can make this 0.007 maybe. And let's do 0.6 here. And we get a bunch of different variations like so. Perfect. And what we're now going to do is take all of this and put it into a node group. And we can then make this the seed, and this is the length. So this is going to be a distance value 0.01 like that, and this is going to be the seed, yeah, and it's going to be an integer. There we go. So this is sprinkle. You can delete those, set defaults, just look at that again. It is quite big actually. We'll see. We'll fix that. So now, how to get this sprinkle onto here? Well, if we do an instance on points node, we can take the sprinkle, put it in the instance, and then look at this. We have a bunch of sprinkles on the surface, but they're all oriented the wrong way. And the easiest way to just connect these is take the rotation, put it in here, and they are now rotated to the surface. But we're not gonna do that because we want to add also some random rotation to the sprinkles. And to do this is use align rotation to vector. And we want to take the normal and put it in the vector and keep it with the Z, because Z is the axis that it's laying flat on. And then you can put into the rotation a random value set to vector. Actually, Blender, I'm sure you're working on this, but add to the random value a random rotation component. I know we can use vector, but it's getting pretty tiring to put in radians, because in vectors, if you take a vector value and put it into the rotation value, you have to put in the rotation as radians. So if I put 360 here, it's gonna be way over, because if I set tau, it's already 360. But I would like to have more control of kind of these values. So 0.1. So we have some little bit variation. So some of them are sunken in and some of them are out. So now we can add more sprinkles. Yeah, let's do 40. Now all of the sprinkles are the same size. So we're going to just choose a random value, set the float, and do like 0.9 to like 0.1. Some of them are overlapping, which you may or may not want, but you can use the distance minimum. To 0.002, 0.003 to kind of get them away from each other, or not to intersect that much. Now, every sprinkle is still identical, and that's why we made this node group, because we can actually just take this and just make as many sprinkles as we want. And to join these into this, we will geometry to instances the node. It looks like the join geometry node, except it's making them into instances. So if I have 4 of them like this, and I click on this pick instance, and I put this instance instead here, you will now see that some of them are different from the other ones. So I can have a little bit different lengths. Like this. And then find seeds that I like for them. Like that. And then if we up the density again, and let's actually just not have that affected too much. Now we have a bunch of sprinkles that are unique from each other. They are intersecting, but I think that will be fine. They can be on top of each other. And we can put this to 0.45 and 0.445 and this to 0.55. So like that. Bunch of sprinkles on top of the icing. Now is again a really good time to clean this up. So that is sprinkle 1. And we can join this with this over here. So now we have sprinkles on the donut. We want to add a second version of the sprinkles. So this is actually a good time. We're going to take all of this and put it into node 3. Seed. Just checking that everything's connected. So this is a node group and it's called points. I'll call it points. No, points dist for distribution. Cleaning it up this way. So we can actually clean this to be much tidier and nicer. And the reason why I'm doing this is because I'm gonna actually do the same thing again over here. And we're just gonna modify this. So integer math, add a random value to that, and then this we're gonna use a math divide by, I don't know, 5 and put it in here. If you just look at how many points we have, and we're gonna do a set point radius. You might be wondering why I didn't keep this inside of here. Is because this is now gonna be rendered, because from geometry nodes you can actually take the points, and if I put this in here and I go into rendered view, you will actually see that it's rendering these spheres, which have what seems to be an endless amount of resolution, which is way better than any UV sphere or icosphere will ever have, and it's super lightweight. So we can actually use this to make some round, beautiful sprinkles. And we're gonna get some nice value for that, and we want to make it like divide by 10. Let's do multiply instead. Let's multiply by 0.1. We're almost done with the sprinkles. Something like that is perfect. And we can use a random value, which also we should have there to the seed. And put this, we're gonna take this seed in here and do a 0.00125 and 0.0019. Put that in there, and now they're slightly different sizes as well. In solid view they will look like these diamonds, but in rendered view you will see them as these spheres. And there we go. We can just put a frame around that as well. Frame sprinkle 2, and then we can put this into here. Put the value into the sprinkles and say secondary sprinkle multiplier. So close by default. So now we can adjust the amount. Oh, I need to put the minimum to 0 and let's do 1 as the max. So I can adjust how much how many sprinkles I have relative to this amount. So this is like the master density. So I put this to 100 and I put this to 0.1. You will get sort of that amount. And then of course we have joined both of the sprinkles into where we joined the mesh and the icing, and that's it. So that's what we did today. The sprinkle 1 and sprinkle 2. Modeled some procedural sprinkles, made a group of them, and then used the points to render this beautiful round spheres. So that's it for the geometry nodes part of this course. In the next part, we're going to look at the shading, and we're going to use some attributes that we created and also maybe create some more attributes to texture this donut procedurally. So you can watch that video right now on my channel, and I'll see you there.